So hello everyone. So in this class we are going to start the new module, that is module 2, and we are going to learn about regular expressions. So these regular expressions are nothing but the language which is accepted by the finite automatas, and they are basically made up of symbols and operators. So the symbols that they are made up of are any symbol that exists in sigma, and the operators are the union, concatenation and the clean star. So these are the basic units that make up the regular expressions. So in this class we are going to learn what is a regular expression, we are going to learn how to define the regular expressions and the language interpretations. So that means when you have a regular expression, how to interpret the language that represents any regular expression, and also how to generate the regular expressions for a given problem statement or the given language. So now the regular expression is something that is accepted by the automata, and it is made up of the symbols that belong to sigma, and then you have the union operator that might connect them, or we may have the concatenation operator that might connect them, and also clean star. So these are the basic units. Now going to the definition of the regular expression. So first thing that we have to know is null. A single symbol is a regular expression. Next we have epsilon. So epsilon itself is a regular expression. So basically what a regular expression does is it looks at the expression and it matches the strings that belong to that expression. So in the previous classes indirectly we have written few regular expressions already. So in the previous class I had mentioned that there has to be an optional A followed by 2 A's, and then there can be any number of B's. So here you can see that there can imagine everywhere that there is a dot, that is nothing but the concatenation, and here in some places we have used a clean star, and A and B happen to be the symbols from sigma. So therefore this was a small regular expression that we had already written and understood. Next, phi matches with the strings which are non-existent. Epsilon matches with the string that has got no symbols at all. Third, anything that belongs to sigma is also a regular expression, such as, for example, A is a regular expression, B is a regular expression, C is a regular expression, provided we have sigma is equal to A comma B comma C. So then individually each one of the elements which are there inside this is also a regular expression. Now these are the basic units. So now we will move ahead to see how the operators can be used in order to combine the first three basic things that we have seen. So the fourth one, I would say, if alpha and beta are two regular expressions. So these alpha and beta can be regarded as anything from 1, 2 and 3. So if alpha and beta are regular expression, then alpha union beta is a regular expression. Fourth one, rather fifth one, if alpha and beta are two regular expression, the combination of them with any of the operators, such as we will say alpha beta in this case. So that means we have to imagine a concatenation operator between two different regular expressions, that is alpha and beta. So the concatenation of two different regular expression is also a regular expression. Next, if alpha is a regular expression, then alpha star is a regular expression. So these are the things that we have to understand from the first three basic units, and we are combining the first three basic units, and more complex regular expressions can be formed by operating on them by union, concatenation and also star. Next, in case if alpha is a regular expression, then the bracket of alpha is also a regular expression. So, that means the regular expression can be placed within the brackets. So, these are the things that we are going to know about the regular expression. So, any string that can be formed by the 7 different expressions that we have defined is called as a regular expression. So, we know the meaning of strings. So, strings are nothing but the combination or a sequence of symbols. So, we may regard point number 1 to 7 as different symbols. So, the combination of any of these in any order is nothing but a regular expressions. Next, we will look into the language interpretations. When we look at language interpretation, our aim is to understand what the language will contain if it is representing any regular expression. So, suppose we have L of epsilon. So, how to understand what is L of epsilon? So, L of epsilon contains only one symbol. So, the entire language is going to contain only epsilon. Next, we have L of C, where C is any symbol which is picked up from sigma, then the entire language is going to contain the symbol C and it will be the only symbol. Next, third one, if we have L is equal to null. So, in this case the language does not contain any element at all. Fourth one, in case we have L of alpha union beta. So, we have seen that alpha is a regular expression and beta is a regular expression. If we have the language that contains alpha union beta, then it is nothing but L of alpha union L of beta. So, for the single elements we already know what it might contain. So, the union of the first language union the union of the second language. Next, L of alpha beta is equal to L of alpha concatenated with L of beta. So, we will pick up all the strings that belong to this alpha regular expression and we concatenate it with all the strings that belong to the beta L of beta strings. Next, we have, if we are talking about L of alpha star, then it is as good as saying L of alpha the whole star. So, L of alpha is easy for us to frame and we will have to put a clean star on all the strings that are within L of alpha. Next, in case we have L of alpha within the brackets, then it is as good as saying that we have L of alpha whole to the power of brackets. So, the brackets is actually not going to make any change to the regular expressions. So, these are the language interpretations that we can do for the regular expressions. So, now we will look into some of the problems where we are trying to design the regular expressions for the given problem statements or the languages. So, when we look at the first problem, they have asked W belongs to A comma B star. So, therefore, you have to understand that the regular expressions should include the symbols from sigma, that is A and B. So, the length is always even, they say. So, the W is always even. So, whenever we have A comma B, even length strings can be formed by repeating two symbols n number of times. So, any such symbols can be written as A union B. So, this will be the first symbol and that first symbol can either be a or be a B. So, the union can be read as a OR. So, this is the first symbol. Again, when we choose the second symbol, it can either be A or it can be B. So, this is the first symbol and this is the second symbol. first symbol can either be a or B, and the second symbol can again either be a or B. So, if the same thing is repeated 0 or more number of times, always this will lead to a even length string. So, this is how we execute the statement. Now, it is always possible for any of the problem statement in the regular expressions to have more than one way of representing the regular expressions. So, therefore, the same thing can be interpreted as the possible two length strings are AA, AB, BA and BB. So, these are the strings of length 2 that can be formed by using the symbols A and B. So, therefore, if we repeat these things n number of times, so then again it is possible for us to get even length strings. So, we will put a union in between all of them. So, therefore, the first time when we are framing the string, we can pick up any one of the symbols, so any one of the strings. So, therefore, you have AA for the first time. So, second time when I repeat, I might choose BA. Third time when I repeat, I might choose AB. So, therefore, depending upon the string that you are framing, you can pick up any one of these any number of times, but any number of times will always lead to a even length string. So, these are the two ways in which we can represent the solution for this problem statement. Next, we have another problem statement here. W belongs to A comma B. So, therefore, we can frame sigma is equal to A comma B. Next, there is some description given about W. So, W contains odd number of A's. So, odd number of A's. So, we have to think about how to generate the odd numbers. So, we know that any even number, when you add 1 to a even number, we always get a odd number. So, therefore, whenever we are framing strings, we have to have even number of symbols and make sure to place a definite extra A so that it always becomes a odd number. So, therefore, we may write this as A and A. So, this will always give us even number of A's in the string, but we are not interested in only this, we are interested in odd number of A's. So, therefore, this is a skeleton where the string that we are going to form, that is a regular expression, will have odd number of A's always. Now, the string is also made up of B's. So, there has to be a possibility to include B's in the string in any number and in any order. So, therefore, the string may start with any number of B's, and after that in between these two A's there could be any number of B's, and also in between this A and this A there could be any number of B's, and also after this there can be any number of B's. So, the B's can be placed anywhere between the odd number of A's that are appearing. So, by doing this you can frame any string that includes A and B, but definitely there are going to be three things. Those are nothing but these two which are repeated, then you have 1. Now, in case I want only a single A, because that 1 is also a odd number. So, we will see whether it is possible for us to have just a single A which is also a odd number of A's. So, we have placed 2 A's here and placed a star. So, therefore, that means this could also be 0 occurrences of these 2 A's. So, therefore, in that case you will just be left with a single A. So, that is also possible with the same expression. So, 1 A is possible, 3 A's are possible, then 5 A's are possible, and so on. Next, we have another problem statement. W belongs to A comma B star. There is no more than one B. So, that means the number of B's can either be 0 or it can be 1, because they say there are no more than one B. So, therefore, the number of B's can be 0 or maximum it can just be 1 B. So, how to place this? So, we know that B becomes an optional part here because there is 0 occurrences of B also. So therefore, we will write epsilon union B. So epsilon union B. So epsilon denotes 0 number of B's and single B denotes 1B. So this is how we are going to write. They have not placed any constraint on the number of A's that can appear on the string. So therefore, an A can either appear on the right side of B or it can be appear on the left side of B, right side or left side, and the number is also not important. So there can be any number of A's and in any position. So therefore, we are going to include a star here and also we are going to include another A star here. So there could be or there could not be more A's in this string. So this is the final regular expressions that we are going to derive for this. So when we take up any of these regular expressions and try to frame the strings, we will see what we get. So you could use this method in order to generate strings either from this or this regular expression. So A star is there. So instead of A star, I choose to put it as A square. Then it will be followed by epsilon union B, and then here I place A cube. So we will see what is the string that is framed from this. So A square will always give us 2 A's. After that, it can be followed by epsilon or B. So I choose B from this expression, from the brackets, and A cube is going to give me 3 A's. So here, when I choose this string, I see that there is at most only one B in the entire expression. So this is a valid string. Now suppose the same thing I pick up and frame another string, but choosing something else from the regular expression. So A square, A is not optional, so A's, 2 A's have to appear here. Next you have epsilon union B. So this time when I have an option between epsilon and B, I am going to choose epsilon from this entire expression. So therefore, we are not going to write anything here. Then next we have A cube. So A cube is going to give us 3 A's. So here in this case, we do not have any B's at all, but it never exceeds 1. So that is what we are looking for. So there has to be 0 or 1A, not more than 1. So this is how you can verify by deriving the strings from the framed regular expression. So we will go to the next problem statement. Here, no two consecutive symbols are same. So whenever you are framing the strings, no two consecutive symbols have to appear next to each other. So that means you have a AA, this is not possible. Having a BB is also not possible. So no two consecutive symbols are the same, but AB is possible and BA is also possible. So now we have only options of having either AB or BA repeating themselves a number of times, because these are the only strings that are having alternate symbols. So therefore, when we are framing the regular expression, we already have an idea from here that it either has to be an AB repetition or a BA repetition. It can't be a AA repetition or a BB repetition. So therefore, the string can either be a AB repetition or it can be a BA repetition. But now it is not enough if we write this, because AB repetition is only possible for us to start from a A. So this is not compulsory that AB always repeats from A. So therefore, you can write here any number of B's can be present. After that, you can have any number of AB's. It is not necessary that it always ends with a B also. So therefore, I may have any number of A after this. Rather, we can't have any number of b's because this will give us a continuous a b b. So, we are going to just write a here, because it is quite possible that we start with a b and we may have to end with a, and in between we need the repetitions of a's and b's. Or when we pick up this ba star, so the repetitions from here we get is ba, 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 ba and so on. But when we have the repetitions of b and a's, it is quite possible for us that we may have to start with a. So, therefore, a is possible here. We give a symbol there, and it is not necessary that this always ends with a. So, therefore, we may end with a b also. So, therefore, we give a b. So, the choice is very simple. We have b here. So, therefore, we can never place a b here because this will lead into 2 consecutive b's. So, it has to be always the other symbol than the one which we are repeating. Also, we are ending with the a. So, a cannot be placed again because it will lead into 2 consecutive a's. So, therefore, the symbol may be a b. So, by writing this expression, we may frame strings of a's and b's which have got no 2 consecutive symbols which are same. Now, we will look into the next problem. So, the problem statements say that obtain a regular expression for the floating point numbers, and they say that we have to assume that a decimal number is in the form of x or x dot y. So, it can either be a whole number or it can be a decimal number. Next, D stands for digits that represents anything from 0 to 9. Next, we have few examples of the numbers that they have given. So, it may have a plus, or there is also possibility that we do not have a sign here. So, the first thing the floating point number is going to contain is a optional sign. So, this optional sign is nothing but an optional plus or minus. Next, we will interpret the next things that are there. So, next it comes with a decimal number followed by a decimal number. So, this decimal number can either be in the form of x or it could be in the form of x dot y. So, that means it could just be d. So, that means nothing but digits, or it can be in the form of digits dot digits. Next, after we have this, it is followed by e, that is the exponent. Next, after the exponent again we have an optional sign, optional sign. So, this can either be a plus or minus. It may appear in the string or may not appear in the string, that is why we call it as an optional sign. So, once we have an optional sign, it is followed by digits. So, this is how we frame the skeleton or the different parts, interpret the different parts which are there in the floating point number. So, once we have framed this, it is easy for us to actually frame the regular expression. So, once we frame the regular expression here, so first we are looking into something that says there is a optional sign. So, an optional sign is given as a plus or minus, but then plus or minus, just by writing this, says that there has to be either a plus or a minus compulsory, but now both could also not exist, therefore, we add a epsilon here. So, either we choose an epsilon or we choose a plus or we choose a minus. In case the number does not have plus or minus sign at all, then we choose epsilon. In case the number has got plus, we choose the plus from the entire expression. If it has minus, then we choose the minus from the entire expression. So, that is the meaning of saying that it is a optional plus or minus, that is an optional sign. And after that we have decimal number. So, this decimal number is nothing but d plus. So, I write there d plus because there has to be one or more number of digits. So, therefore, we do not use a star here which says 0 or more. So, it does not comply to the rule of framing the floating point numbers. So therefore it is d plus. So at least one digit has to be there, but it can be more also. So after we place this, then we again move to the optional part, which is nothing but the dot, which is an optional part. So therefore we say epsilon union, that means epsilon or dot, followed by d plus. Epsilon union dot d plus. So suppose if it is in the form of x dot y, I will be placing x from this d plus, then I will be picking up dot from here, and then I will be picking up y from here. So that is what we mean. Then x can either be 56.65. So in this case 56 d plus, so that is nothing but it is acting as d square. So two symbols are there for d plus. Then we pick up the dot from here as it is, and then again this d plus is nothing but d square. So that is how we are going to interpret each one of them. So once we have finished with this, we have to look for E followed by optional sign and D. Again, the entire thing whatever we have placed here is optional, because we have plus 3.0 as an example. So when we look at plus 3.0 as an example, that means it does not have any exponent part at all. So this entire expression becomes a optional part in the floating point number. So therefore we start with epsilon union, because in case the entire part is not present, then there is no need to write anything here. So epsilon union followed by again E. So I will try to continue here as a single expression. So we have already written that it is epsilon plus u, that is nothing but epsilon union plus union minus d plus, then we have epsilon union dot d plus, and then we have epsilon union. So we are making this entire part as optional now. So epsilon union, then E. In case exponent is present, we will be picking up something from this. So we will not, between this or and this or, we are only picking this or in case we have the exponent part. So E followed by again optional sign. So optional sign is again given by epsilon union plus union minus. So once we have finished this, it has to be followed by a d plus. It has to be followed by a d plus. So therefore we will close all the brackets here. So this is the final regular expression for the floating point numbers. Thank you.